Hi, this is Richelle Tuvillo, and this video is a demonstration of correspondence analysis using R. I suggest you watch the part 1 of this video so that you will have a background about the tutorial. Now, if you watch already the video, now let's print the output. Okay, let's start with the demo of CA or corresponding analysis using R. This is how R would look like if you have installed that already in your PC. If you haven't installed it yet, better install it now so that you can follow with the R script. I prefer R Studio. It is a separate download and installation, but of course it requires R. We may minimize or close R for the meantime because I will be utilizing R Studio. Then we will close this R script for exploratory factor analysis and discriminant analysis. This was our topic the previous meeting. Now we will open R for my we will open my R script for the CA using my dataset phys-ed. Here it is. Now let's change our working directory. I've changed its location after I'm through with my report, so better follow that folder so that everything you save will go to that working directory. If you notice, I practice a lot of times before I can present this topic with confidence in our class. Let's see if we can open the data ed. No, it's not found. Therefore, we need to import it first. We will import it as a CSV file. A few tries before I was not able to import it correctly because the student number was always included in the data. I want to skip that here because if not, I'll change the column number that will be analyzed in the R script. Change the name of phys-ed to directly ed. Rule of thumb here, the shorter the better. At least 2 or 3 initials or abbreviations, the better. Then skip the first column. Alright. Checking if I missed something. I hope not. Then import. Now we're ready to go. Then we will create a data frame composed of only 2 qualitative variables, and they are columns 2 and 3. Then I will store it as ed23. We'll make this console bigger. Here it is. The class section and their senior high school strand. 2 categorical variables. Next, we are going to make a contingency table out of it. Then let's view our contingency table, or for some they would call it a cross table. Here it is. So 3 students from section A will take the gas strand, 7 out of 33 will take the UMS, and the remaining 23 will take the STEM track, and so on. From here, the rest will be automatic if you follow the R script provided here. You may also explore or experiment the syntax. Probably you may discover something. If you want my dataset, make sure to like, share, and subscribe to this channel for more videos. I'd be happy to send the dataset phys-ed to you through my email rotuvillo@gmail.com. Now we'll test for independence using chi-square. I will explain more of this in my next videos after I'm through demonstrating the CA using SPSS and XLStat. Just take note that the chi-square test for independence is 36.012 at degrees of freedom equals 4, and it is very significant at p equals 2.87 times 10 to the negative 7, very small. Thus, we reject our null hypothesis that class section is independent of the intended senior high school academic strand. Now we accept our alternative hypothesis that there is dependence. Now we will get the row and column profiles. This serves as the weight in computing for the inertia later. Then we will load the factor minor, which is necessary before we can run the function CA. If you have not installed it, okay, so let's see. You go to Tools, Install Packages, then type factor minor, then install. But I'll close mine since I've installed it already. Probably it will take you 10 to 20 seconds to install it in your PC depending on your internet connection and processor speed. Now since we loaded factor minor to run the CA function with the syntax CA open ed23.ct close stored in ed23.ca, you don't need the ed23.ct in contingency table if you are only after for the graph and the eigenvalues. Later I will show you how, but for this video we will show the details of this function for analysis. Probably you may get something from it for your research later. So this is the graph that we are aspiring for. Further discussion of this will be in my next videos. Then the eigenvalues. Again, we will reserve the explanation and the interpretation of this data in my next videos. When I reported this topic, it took me at least 2 hours to discuss, including the concepts and the interpretation. So stay tuned. Next are the plots. Without the coefficient of 1 over the square root of lambda s from the barycenter, this is the actual position of the categories if we plot them simultaneously without that expansion. But because of that factor 1 over the square root of lambda s, we can expand and plot it simultaneously so that it can aid us for better interpretation. This bar plot is essential only if we have 3 or more categories or variables, just like in multiple CA. But here in simple correspondence analysis, it is not a big deal because we have only 2 dimensions. And last, let's load our package Factor Shiny. Install it first if you don't have this package yet in your R. This will give us a user-friendly interface to summarize all we need in the factor minor CA function. This is only possible if you had already run the CA to your dataset. After loading it, let's see the interface. It will direct you to a web page. So here is our graph now. You click this button for the values, another button for the summary of the dataset, and of course your data. There is also a button for download so that you don't need to copy and paste the values or screenshot graphs. Just explore it if you are already in this stage. Now to summarize what we did, I have a brief syntax here if you are only interested in the eigenvalues and the graph that is very important to your research. First, I copied only the necessary syntax. Let's clear first the console. Okay. Now let's try to view the dataset ed. Sometimes you need to restart the RStudio. If it shows us the correct dataset, then we are ready to go. Next, we need only the class section and the senior high school strand. That's columns 2 and 3. Let's check if it is correct. Perfect. Load the necessary package factor-minr. Perform the function. Just ignore the errors that will happen because we did not use a contingency table. The program complains that the variables are not quantitative, which is correct anyway because we are dealing with a qualitative or categorical variable. Just proceed to summary anyway. Check the summary. Very good. Load our factor-shiny package. Then run it. Excellent. I hope you learned a lot from this demonstration of CA using R. Next statistical software that I am going to demonstrate is using SPSS. See ya!